FHIR or FHIR stands for Fast Healthcare Interoperability Resources. And it is a standard by HL7 that's being adopted at a rapid pace around the world. In fact, more than 75% of companies claimed that they used FHIR in one form or the other to connect to EHRs. In this video, we'll be taking a look at what FHIR actually is, how you can look at a FHIR resource and understand what it means, and what you can do with it. So here I'm on the FHIR website, and this is just if you go to hl7.org/FHIR, you'll get here. And first I'm going to explain what a FHIR resource is. Now, a FHIR resource can be thought of as the smallest unit of exchange. It's this atomic thing where you describe something like a patient or an encounter or a medication. Any category of information that's available in healthcare can be represented as a resource. Now on the FHIR website, you have a ranking of FHIR resources by maturity level. This is a good way to look at it because FHIR resources are evolving all the time. There are new resources being added, some are being deleted. And one way for you to understand which resources are really being used a lot is to look at this N flag. And this stands for normative, which means that it's not going to break much and people all around the world are already using this particular standard. So now if you take a look at the resource itself, in this case patient, they explain what it actually does. So for example, here you have the demographics and other administrative information about an individual or animal receiving care or other health related services. So this is a resource that's supposed to be used for representing data about a particular patient. It could be an individual or an animal receiving care. So that's how they define patient. Now there's a bunch of documentation on the scope and usage, but finally you will end up on this section called the resource content. Now this explains what data fields are supposed to be present in the patient resource. Now there are multiple views of this, some like looking at JSON, some like the UML, but the structure will tell you the most information and it's the most concise way to understand what is expected in a FHIR patient resource. Now, before we get into this, if you just go to the example section and click on JSON or XML here, you will see an example of what a FHIR patient resource actually looks like. Now, this is a better example of what it should look like than just going through the standard and understanding all the different fields. So I advise that you first take a look at the JSON and then you come back to this particular resource content section. Now, you have different fields here and these are called data elements in FHIR, and each data element has a cardinality and it has a type and it has a description of what it is actually supposed to represent. So in this case, you have something called the identifier, and it is supposed to represent an identifier for this patient. So this could be like a hospital ID number, this could be an NHS number, it could be the social security number or the passport ID or a driving license of a patient. Now, the cardinality tells you what is the minimum and maximum number of times this particular element can occur in the FHIR resource. So here the 0 represents the minimum. So it's usually minimum and then 2 dots and then the maximum. So 0 represents that it is optional and you don't have to have the FHIR identifier in a patient. And the star represents as many times as you want, basically infinity. So you can have as many identifiers as you need. Now the type actually represents what this identifier is supposed to look like. Now, again, if you are smart, which you probably are, you will look at the JSON example here and just understand what the identifier is supposed to look like. But a formal definition of what exactly goes in here is defined by the type here. So if you click on type, it scrolls down. This page usually takes some time to load, but it finally scrolls down to this structure view of the identifier data type. Now, this is very, very similar to the FHIR patient structure view that we just saw. And here again, you have other elements that are being used. So for example, the use is supposed to be a code. And again, they say it can only be one of these things. And this is again another data type, which is all defined in the FHIR data type here. Now, some of these data types are primitive, like for example, code is just a string and it can be checked using a regex. So this data type can be bound to a value set. And that's exactly what they've done here. They've had like code can only be one of these, right? So there are other data types which are also complex. So for example, codable concept is again yet another data type, and you have yet another data type here that represents what this is supposed to look like. And finally, coding has only URI, string, code, string, Boolean. All of these are primitive data types. So the primitive data types, all of them start with a small lowercase letter, and the more complex ones start with an uppercase letter, just so you can identify what is what. Now, the type page of FHIR has everything you need to know. It has like the primitive data types, the general purpose data types. And if you have a lot of time, you can go and like understand each and every data type. But it's not necessary to understand what a FHIR resource is. All you need to know is you see an example, you come back and check, okay, you have these different elements, and you know the cardinality, which lets you identify whether something is going to be like an array or is it going to be a direct reference. So for example, in this case, let's take a look at identifier in the example again. It is in fact inside an array. So there are multiple occurrences of this possible. So it's inside an array, but whereas active is just a Boolean and it can either be true or false. And active also can only occur once, at most once. So it can either be 0 where it's not present, or it can occur only once. So it doesn't need to be inside an array. So this is basically how you read a FHIR resource. If you look at the FHIR patient resource, you see a lot of elements that are completely optional. So they all have the cardinality of 0 and then something. So technically, someone can represent a FHIR patient resource with only, let's say, the resource type of patient, and that's still a valid FHIR patient resource. Now, if you want to exchange information in the real world, you need more constraints than just this. Now, the International FHIR Patient Resource is a framework for other people to extend and constrain this resource a little bit more for their own needs. Now, that is where profiles come in. So profiles are a way to constrain and extend a FHIR resource for your own needs. Now we'll take a look at an example of a FHIR profile. So this is the US core patient profile. So now this is how the US has decided to extend and constrain the patient resource. And we'll just take a look at what this looks like. Now there is a bunch of documentation. They provide a good documentation on what needs to be present, what needs to be supported, and so on. But we can do all of this using this thing called the differential table. Now, the differential table only shows the differences of this profile as compared to the base FHIR resource. So in this case, if you want to look at all the elements, you have to go to the snapshot table. Now, this will show you everything in the original FHIR patient resource as well as the changes that they've made. The differential table will only show you the differences. Now, the first thing that we see is there are a bunch of new elements here. So we have race, ethnicity, tribal affiliation, birth sex, gender identity. Now, these are all called extensions, and these are a way to add new fields to the FHIR resource. So in this case, the US decided that they needed all of these additional fields, so they went and added those. The identifier actually is now mandatory. And if you take a look at the FHIR patient resource, the original one, this was actually 0 to many, but in the FHIR US core profile, the identifier is now mandatory. Now you can change other things about an element apart from making it mandatory. You can even constrain this to, let's say there can only be a maximum of 2 identifiers. But let's look at what this S stands for. The S stands for must support, and it's a way of FHIR telling you that this particular element, if your database has this particular element, you need to send it to other systems, and you should also be ready to receive this within your database if another system were to send this information to you. Now, a must support element need not always be mandatory. So for example, here in gender, or let's take a look at birth date. So the birth date is a must support element, but it's still not mandatory. So what that means is that if you don't have this data, that's completely fine. You don't have to send it. You're not required to send it if you don't have it. But if you have this data, you need to send it to the other party. And if another party is sending you data with birth date, you should know how to handle this and how to receive it in your system and store it within your own system. Now let's take a look at what extensions are and how you're supposed to interpret them. Now the FHIR profile here has a bunch of extensions like race, ethnicity, and so on. And each of this is actually part of this field called extension in the base patient resource. Now in FHIR, every field has this thing called extension. So if we take a look at race, and let's try and understand what this looks like. They explain what this looks like. There's a text summary, and then there's a differential table. And this extension itself actually has other extensions. So again, in FHIR, every single field is extendable, and you can add this other field called extensions in a field. So what this actually looks like in practice is that, let's go back to the example here. Let's take a look at the child example. Now the extension field here is just the built-in field that's available in all FHIR fields, so including the FHIR patient resource. And inside that, we now have the first extension. And this first extension has the URL of US core race. Now this is supposed to be read along with, let me quickly duplicate my tab to show you side by side. So this is supposed to be read with the US core profiles race here. So this race is supposed to be on the patient resource, and it's supposed to have a URL of US core race. So this is what they're doing. So the FHIR patient resource has an extension, and there is the URL of US core race. And then under the US core race, which is, again, there is an extension within the extension. So this is, again, the second level of nesting of this extension. Underneath that, they say that it should have 2 separate categories. So then there are 2 separate extensions here, one with a URL of OMB category and another with the URL of text. And they don't have this thing called detailed because it's not must support, it's not mandatory, so they've left that out. So this, let's just read what this means. American Indian or Alaska Native, Asian Black or African Native or other Pacific White Islander. Okay, so they have a coding system for OMB category, and if you click on that, you'll see what are all allowed in here. So there is American Indian or Alaskan, there is Asian, there is Black, and there is a bunch of different codes, including unknown, asked but unknown, and so on. So all of that can go in here in this value coding, and this value string is just supposed to represent the textual representation of this particular extension. Now, you may be a little confused as to why is this a coding whereas this is a string. Now that's because extensions in itself can have this thing called value X, and the type of this, or the name of the field, is determined by what type it actually is. So let's take a look at extension. Now let's close this. So let's make this a little bigger for you. So extension has URL and value X. Now the value X can be one of these, so that it can be value Boolean, it can be value integer, it can be value address. This is all of the FHIR types that are available. Okay. Now, depending on which type they claim something to be, so in this case, it was supposed to be a string. So in the actual FHIR resource, this will be value string. And in this case, it was coding, so it's supposed to be value coding in the actual FHIR resource. Now, let's take a look at one final thing, and that is the official URL or the canonical URL of a FHIR profile. So now whenever you use a FHIR profile in your resource, you're supposed to also include in the meta. So there is this thing called the meta.profile. You're supposed to include which canonical URL or which profile you're talking about and the version of the profile. So the version can be found here. So again, the version is completely optional, but at least you should include the canonical structure as to what FHIR profile you are extending on, so that they understand all of these extensions and they can really make sense of this data that you have. So now that you know what a FHIR resource is and how to read it, what do you do next? So this is where exchange paradigms come into the picture. So FHIR allows you multiple ways in which you can exchange these resources. So one of it being HTTP REST, the other being document, message, services, persistence, and subscriptions. So we will take a look at a few of these in brief, starting with HTTP REST. So this is a way in which you can do all of these operations like read, update, create, delete, and much more through standard HTTP APIs. So when I say HTTP APIs, when I'm looking at this page, I'm essentially doing a GET request on this page, but using programming languages and using tools like Postman, you can also do other operations like post, put, and so on. So here, what you are seeing here is all you need is a URL, and the FHIR server is on that URL. And if you do something like get FHIR URL / patient, you will get all the FHIR resources on that URL. So for example, let me go to happy.phir.org/base r4/patient, base r4/patient, and you get a list of all the patients that are on this server. So now what you actually get back is a resource type of bundle. This is a way in FHIR to put multiple resources together. And then in the entry, we actually see actual patient resources that are on this FHIR server. So this is a way in which someone can request information from a server and you can get back all this information. There are ways in which you can create or update or delete the resources on this server as well. And let's just take another quick example. So if I wanted the details of a very particular patient, in this case 595250, I can do this and I will just get that one patient and I'll get that resource in the response. So now this is how FHIR REST basically works. There's a lot more to it, and there are other videos where we cover this in more depth. But yeah, that's how FHIR REST works. Now there are also documents. So now what you do with documents is very similar as to REST, in which you got a bundle back when you wanted a list of patients. You can put together all resources that make sense into a bundle, and you can just send it like you would send an email. So for example, if you take a look at ABDM India profiles, so this is again a FHIR profile specific for India. And if you take a look at how they are implementing FHIR, you can just take a look at the ABDM profiles, and they have multiple clinical documents. So here, let's take a look at OP consult record. So they say that, oh, okay, this is a composition. And now that you know how to read this, they say that, this composition is a type of composition, and you're supposed to have all of these different entries. And you put this composition in a bundle and you include all the other resources in the same bundle. And this whole bundle FHIR resource, you can send it across through another protocol. So in this case of ABDM, they send it through the government's own proprietary sort of APIs, but you could also send this through standard FHIR REST. Now, messaging is very similar. For example, if you take Nafis, So this is a implementation guide for Saudi Arabia where you exchange information for insurance claims. And here what they do is all of the information that you send are still FHIR resources, but instead of just sending and forgetting like documents, you are able to get a response back. Now the bundle looks a slightly different because the first element is not a composition, it's actually like a message header. And I'll see if I can find an example here. Yeah, I mean here we go. So you have a bundle and you have an entry with the first resource being a message header, and then you have references to all other resources in the message header. So this again is one of the other FHIR paradigms. Now, if you combine FHIR resources, FHIR profiles, and FHIR paradigms, and then write a lot of documentation of how this is supposed to be used in the real world, you have what is known as an implementation guide. This is the US implementation guide, and we saw NAFIS, which is again another implementation guide. We saw ABDM, which is yet another implementation guide. Now, FHIR has a implementation guide repository. You will see hundreds of different implementation guides all across the world. So there is US core, there is Australia, AU base, AU core, CCDA on FHIR, how to do structured data capture. But all of these just build on top of the different concepts that we saw in this video. So all you need to know is FHIR resources, FHIR profiles, FHIR exchange paradigms, and how it all comes together in an implementation guide with some documentation. And you can now say that you know what FHIR is. So thank you for sticking around till the end of the video. I think this has been great, and I hope you now know a lot more about FHIR than when you got here. So my name is Dr. Sidharth Ramesh, and we do everything health IT related on this channel. Thanks a lot for watching. I'll see you again in the next one.